Welcome back, everyone. In the previous video, we deployed a Java application on Kubernetes, but in real-world applications, we never hard-code values like messages, URLs, or credentials. So in this video, we are going to solve that problem. Today, we will learn how to use config maps and secrets in Kubernetes. Let's visit the application again. We have created two more endpoints. First endpoint, /config/message. This will return a message from configmap. Second endpoint, /secret/message. This will return a message from secret. We use @value annotation to directly read environment variables. Simple and very practical. Now let's understand the basics. ConfigMap is used to store non-sensitive data, things like messages, configurations, feature flags. Secret is used to store sensitive data, things like passwords, tokens, API keys. One important point. Secrets are stored in base 64 encoded format in Kubernetes. So remember this: configmap for normal data, secret for sensitive data. I have added two more files, configmap.yaml and secret.yaml. Now let's go through them one by one. Now let's understand the configmap and secret files, line by line. This is very important because in real projects, you will refer these files often. Let's start with a config map. First line, API version v1. This tells Kubernetes which version of API we are using. For config map, we use v1. Next, kind config map. This defines the type of resource we are creating. In this case, it is a config map. Next, metadata section. This contains information about the object. Inside metadata, we have name, app-config. This is the name of our config map. We will use this name later in the deployment file. Now comes the most important section, data. This is where we store our key value pairs. We define a key, config message, and its value, hello world, from config map. This value will be injected into our application. Now let's move to the secret file. Again, API version v1. Secrets also use the same API version. Next, kind secret. This tells Kubernetes that we are creating a secret resource. Then metadata, and the name is app-secret. We will use this name when mapping the secret to our application. Next, type opaque. Opaque means this is a generic secret. We are storing simple key value data. Now the data section. Just like config map, this stores key value pairs. But here, values must be base 64 encoded. We define the key, secret message, and the value is the encoded string. This represents hello world from secret. So remember this clearly. Config map stores plain text values. Secret stores base 64 encoded values, and both are injected into the application using environment variables. Once you understand this structure, you can easily work with any Kubernetes configuration files. In order to generate base 64 encoded string of message, I used a PowerShell utility. Let me show you that command. This command generates base 64 encoded output of the message. Let me copy this data to secret. Before deploying to Kubernetes, let's test this locally. We can pass environment variables directly while running the application. In IntelliJ IDE, we can pass it in this way. Now, before deploying to Kubernetes, let's first test our application locally. Once the application is running, open the browser and hit Application Endpoint. First, test /config/message. You should see Hello World from local config map. Next, test /secret/message. You should see Hello World from local secret. If both endpoints are working correctly, that means our application is ready. Now let's build the Docker image. We will create a new version, v2. Let's run the docker build command. Tag the image as your Docker Hub username /java k8s integration v2. Once the build is complete, we need to push the image to Docker Hub. Let's run docker push for the v2 image. After pushing, let's quickly verify the image. Open Docker Desktop. Go to Images section. Search for your image with tag v2. Make sure it is available locally. This confirms that the image is built correctly. Now we also need to configure environment variables in the deployment. This is where we connect our application with configmap and secret. Under the env section, for configmap, name, config message value comes from configmap key, config message, and configmap name is app-config. For secret, name, secret message value comes from secret key, secret message, and secret name is app secret. This step is very important because this is how Kubernetes injects values into our application. Now let's deploy this updated image to Kubernetes. Before we apply the deployment, there is one very important step. We need to create the configmap and secret first. Why is this required? Because our deployment is referring to these resources. If they do not exist, Kubernetes will not be able to inject the values into the container, and your pod may fail to start correctly. So first, apply the config map. Then, apply the secret. Let's apply them one by one. Run this command, kubectl apply -f configmap.yaml. Next, apply the secret. Run this command, kubectl apply -f secret.yaml. Once both are created successfully, now we can deploy this updated image to Kubernetes. Open your deployment YAML file. Update the image tag to v2. Apply the deployment again using kubectl apply. Kubernetes will automatically pull the new image and restart the pod. Wait for the pod to come into running state. Now let's test the application again. Call /config/message. You should see Hello World from configmap. Call /secret/message. You should see Hello World from secret. And that's it. We have successfully tested configmap and secrets. Thanks for watching. Do subscribe, like, and share. See you in the next chapter.